In this video, I'll show you how to solve the ALEKS problem called converting the number of atoms and mass of compound. There are two versions of this problem, and I am going to show you how to solve both versions of the problem. So in this particular version, we have been given a mass of a particular compound, and we're asked to calculate the number of atoms in that particular amount of this substance. This is the strategy that we're going to take. We're going to start with the number of grams of this molecule that ALEKS has provided to us. We are going to convert that into moles of that molecule using the molecule's molecular weight. And then we are going to convert the moles of molecule into the moles of atoms that ALEKS is specifically asking us about. For this problem, it's magnesium. And then from there, we're going to convert that into the individual number of atoms, which is more specifically what ALEKS is asking us to do. So let's just start working on this. We're going to start with the grams of the molecule, and this is a number that ALEKS provides to us. It's telling us that we have 120 grams, and I'm going to write the formula of this molecule, Mg2SiO4. Now, the first step in our calculations is to do a gram to mole conversion. That is done using the molecular weight of this compound. So I'm going to start by writing units down on the bottom. Grams of Mg2SiO4. That's the unit that we're trying to get rid of. We want that to cancel, and we're trying to convert into units of moles. Mg2SiO4. This relationship, this conversion factor, is the molecular weight of this molecule. So we are going to want to pull up a periodic table, which I have done on the side, and add up the molecular weight for this compound. I've got a periodic table on a different screen right now, but as I'm looking at it, I can see the molecular weight of magnesium is 24.305, and for silicon, it is 28.086. And then for oxygen, I'm just going to call it 16. Now, it is really important in ALEKS when you're calculating these molecular weights to use in a gram to mole conversion, you want to use all of the significant figures off the periodic table, even though it is kind of tedious. ALEKS is pretty picky about that. I have gotten problems wrong before because I have a tendency to round atomic weights. So adding up this mass, I've got 2 magnesiums, which means I need 2 times the mass of the magnesium. And then I'm going to add 1 silicon, just 1, 28.086. And then I'm going to add 4 oxygen atoms. And I'm getting a mass of 140.696. So that means that 1 mole is 140.696 grams. So this first step accomplishes this part of the conversion. The next thing that we need to do is convert from moles of this molecule into moles of the atom that ALEKS is specifically asking about. And for my problem, it's magnesium. So I need a second conversion factor. This time I'm trying to get rid of this unit of moles of Mg2SiO4. So we want to put that unit down on the bottom, moles of whatever your compound is, down on the bottom, and then up on the top, we're converting into moles of whatever atom ALEKS is asking you about. For me, it is magnesium. Now, for this conversion factor, we're going to use the formula for the molecule. In every 1 molecule or 1 mole of molecules, we have a total of 2 magnesiums. So whatever the subscript is on the atom that ALEKS is asking you about, that's your conversion factor. Okay, so that step did this, convert from moles of molecule into moles of atoms. And then the last thing that we need to do is convert from moles of atoms into the number of atoms. So it's one more step. And again, we want our moles of magnesium down on the bottom because that's the unit that we want to cancel. And we want our atoms of magnesium up on top. Anytime we're converting between moles and atoms, we're using Avogadro's number. 1 mole is 6.022 times 10 to the 23rd, whatever it is that we're talking about. So let's take a look at how all these units are going to cancel. Our grams of Mg2SiO4 are going to cancel. Moles of Mg2SiO4 will cancel. Moles of magnesium will cancel. And we'll be left with the atoms of magnesium. And so we're going to use periodic table. That's way more math than I'll try to do in my head. And 120 divided by that 140.696 times 2 times 6.022 times 10 to the 23rd gives me a large number, which I would expect because we are calculating the number of atoms of something. 1.0 said 4 significant figures, 1.027 times 10 to the 24. ALEKS does want you to include a unit symbol. For this version of the problem, the unit is atoms. And 1.027, it doesn't want us to write the type of atom, like it doesn't want atoms of magnesium, just wants us to write atoms. And actually, now that I'm thinking about it and now that I'm looking at it, there's no unit symbol on that at all. So if you're doing the problem where it wants you to calculate the number of atoms, no unit, just write the number. Unit symbol if necessary. This would be only if you are calculating the mass of something. Now, as I said at the beginning of the video, there's 2 different versions of this problem. In the other version of the problem, it's asking you to perform calculation in the other direction, meaning this series of steps, but proceeding from right to left as I have written it. So in this other version of the problem, ALEKS is going to provide you with a specific number of atoms, and it wants you to figure out what mass of the molecule would give you that number of atoms. So let's just pretend with this problem, let's just pretend that that's what ALEKS is asking. And if it was like that, it would say calculate the mass of the molecule or compound. It would give us, it would say the name, that would have 120 atoms of magnesium. So that would be the second version of the problem. And for that, we would start with, in that version of the problem, we're moving this way in our little flow chart here. So we would start with the number of atoms. That would be 120. And then we would want to convert from atoms into moles. And again, that's going to be using Avogadro's number, 6.022 times 10 to the 23rd atoms in 1 mole of magnesium. And then we want to do the next step where we're converting from moles of atoms into moles of the molecule. So we want moles of magnesium to cancel. We want to convert into moles of our molecule, Mg2SiO4. We're using the stoichiometric coefficients from the chemical formula, 2 magnesiums for every 1 mole of Mg2SiO4, and then in the last step we're going to be converting from grams to moles. And if you're comparing this equation to the first one that I did, you're probably noticing that all of the conversion factors are upside down. So when you're doing this conversion in the opposite direction, the conversion factors are all upside down, flipped upside down. Now, I'm not going to do the calculator math on this. This is just showing you how you would set it up for the other type of the problem. You would do all the math on that. With this, your atoms cancel, your moles cancel, your moles cancel again, and you are left with an answer that has a unit of grams, and that is when ALEKS wants you to include the units in your answer.